welcome to the phenomena session 2 of the MINK phenomenon series. This is the 912 breakout room. Recording it again because we had a technical issue before. So while there's not other teachers really participating in this, hopefully we can still explain everything that you need. My name is Scott King, and my contact information is there on the screen. If you need to get a hold of me, if you have any questions about this, feel free to contact me. And also, you'll hear more from Christine toward the end of this presentation, but she might interrupt as she reminds me to say a few things from time to time. If you want to get a hold of Christine down there, you can get her contact information as well. So today we're talking about what makes an academically productive phenomenon. And it's not just simply, can you pick anything random and use it in your classroom? Not all of them are going to be productive. And we are going to have several which are not really good phenomenon to begin with. And in our last series, we did talk about what makes a good phenomenon. Now we're going to actually look into the standards and find one which is academically productive. So there's a couple of things we need to do this, and it's we have to analyze our standards and know, what are we trying to teach towards. We're going to select a phenomenon that'll work for the bundle of standards that we're going to be using in our classroom. And then one of the key things is we're going to write a student explanation to make decisions about the phenomenon. If a student explanation is not detailed enough or can't get quite where you want to get to, then we need to pick a different phenomenon to work with. So unwrapping standards is not always a favorite thing for people. And we need to know why we have to do this. And it's simply this, that the standards are incredibly complex. They are packed and they are loaded. If you look at the standards for physical science, chemistry, all of chemistry exists under like one standard. It is too complex in that standard to just think you know what it says. So we have to unwrap them and find out all the pieces of this. Same thing happens in biology as well and some of the other standards. We have to have teacher sense making. And in this case, what we're looking at is that the teacher has to know what you're trying to talk about. What are the standards trying to get to? If you don't understand it as a teacher, how do you expect your students to be held accountable for the information on the state testing? And of course, we need to look for a relationship to events in our universe. That's just a basic phenomenon component there. And a lot of that will happen in the standards. You will actually see good examples of things we're trying to explain in the standards as well. And even just simply unwrapping the standards helps you with idea generation. As you read through them and as you read through the framework, you will see a lot of examples and a lot of explanation about how they came to that particular set of standards or what those mean in the 3 dimensions. And so that's what the idea generation will help you with. So here's a bundle for you today. I am a biology teacher. Currently, while I have taught a little bit of everything, I chose to pick a life science standard. So here we have a bundle. It's got 2 standards that I've picked about heredity, inheritance, and variation of traits. They're all about how DNA becomes proteins, how they're passed on from one parent to children or from one cell to another cell, and how errors in this process can cause mutations and other issues. So within that, we would pick a standard, and a particular standard here would be this one. So we're going to construct an explanation based on evidence for how the structure of DNA determines the structure of proteins, which carry out essential functions of life through systems of specialized cells. Taking this standard, I mean, that's a lot of information to unpack and unwrap. And there's also some assessment boundaries there. And so we're going to start the unwrapping process. And you can see on the screen there the bit.ly link for the document I'm going to show you in just a minute. As we unwrap this, you'll see that link in just a minute as well. But unwrapping starts fundamentally from the standard itself. So here's the NGSS standard for LS1-1. And it shows the 3 dimensions and the pieces that go with that. And we're going to put that into a document that looks like this. Now you guys have access to a blank document. You can see the link on the screen there. And also the standard document again that I'm going to share with you that I've started to unwrap this one. The links to these and all this stuff will be in the MINK hub as well. But we're going to break it apart and use a document like this one to help us break it apart. There are many different documents you can use to do this. This is just the one that we're using. So whatever program or system you guys have. When you unwrap the document, this is what you might see. Now, I have already started this one for you guys, and I put in a lot of color coding in here to help explain things. I know it's a little busy right now, but it'll make sense. But in this document, and you'll start with a blank one, you're going to first put in the standard that you're going to use. You're going to put in your SEP, your DCI, and your CCC. This is all just copy and paste from the NGSS standard or your state standards. Now, as you scroll down, we're unwrapping the standard, and we're looking for our unwrapped skills, our verbs, our unwrapped concepts, the nouns, and the performance criteria or considerations. Now, you can see here, this is a lot less chaotic. I have my verbs in red, my nouns in blue, and my considerations in pink. And when we go back up here to our standard, you can see I'm going to look for my verbs. I'm going to start my performance standard, my PE, construct an explanation based on evidence. So my verb here is construct. Noun is explanation, and it's based on evidence. And that's what's going to come down here. I'm going to construct an explanation based on evidence. Now, I went ahead and added a little bit more information down here about what's the explanation for. And when I go up to my PE, I see that's about the structure of DNA and how that relates to the structure of proteins. So here I have the explanation of DNA structure and protein structure. As you keep reading, you're going to find some more pieces of information in here. So in my SEP, again, I have constructing explanations. And this time my constructing explanations is going to be about supported by multiple and independent student-generated sources of evidence. So I threw that down in here in that same row of this box because I'm constructing and designing solutions for that. Again, I keep going through, construct an explanation based on the valid and reliable evidence. So I'm going to copy and paste that in here because I totally didn't do that yet. Doing it live for you in a recording. Let's see here, make sure it's a copy. And we're going to also put that in this box here. And now we have it based on valid and reliable evidence. There we go. Then I'm going to go to my next verb that I find along the way, and that's going to be in my cross-cutting connection over here about investigating systems or structures. And then system and structures are my noun, and my criteria about that's about the properties of materials and different components. So I'm going to come down here to investigate systems or structures, properties of different materials, whatever. Just copy and paste those down there as you go through. The last column you'll see here is the level of rigor. And this I picked from the depth of knowledge charts, the wheels and stuff, where it shows what depth of rigor you might have. I know they're coming out with some different versions of those, so whatever you choose to look at your depth of rigor, that's where you can go for that. Construct and design were level 3s. Determining the structure of proteins was a level 2. Investigating was a level 3. And so that's where I picked those. Further down on this chart, you're going to see about general performance conditions. This isn't always used, but you're looking at assessment boundaries here. So if I go all the way back up to my PE, you can see in the gray, my assessment boundary says things that's not going to be included. So when I scroll back down, again, things that are not going to be included. There also might be some other pieces of information you'll see in there that are overall general conditions. So like it must be consistent with scientific ideas, principles, and theories. And I know it's in here somewhere. Oh, right here. Consistent with scientific ideas, principles, and theories. So that might be another overall condition that you put in there. The content context. This is in yellow here because this is coming from my DCI. I talked about everything else with the DCI. This is the content piece. So I'm going to pull out the key content parts. The system's specialized cells. Cells contain genetic information. They code for proteins. And that's all going to be right in here. Related practices. What other science and engineering practice might I use? So if I'm talking about my original one here about constructing explanations and designing solutions, I'm looking at developing and using models as maybe a related practice. I might use a model in my classroom of protein sequencing and things like that. Other cross-cutting connections that we might be able to use to look through this. So maybe I'm also going to add patterns. as well. So let's just write that in here. Clarifying terms. What are the definitional terms that we will need to know to be successful? These are going to come from your framework. These are going to come from your PE. Maybe we talk about a protein sequence coming from a nucleic acid sequence. Well, codon doesn't appear. But I know to have that, I'm going to have to talk to my kids about what a codon is. So let's define those terms up front in our unwrapping document so we make sure that we cover all of those as we go forward with our unit. And then our learning targets, things that they might be able to do. So in this case, I'm talking about melanin. I can explain the role of melanin in the body. Now, they should really be in three-dimensional language. And again, you can write the level of rigor over here for that particular statement. But you list out all the I can statements that students can do in this particular place. So you make sure that you're addressing all those things students should be able to do at the end of the unit. So we're going to start analyzing it. And there's a couple of things we need to know of what our steps are going to be to do this. And one is to look at the framework text as a guide for our unwrapping and our understanding of phenomena. We should not use our own ideas of what we think should be taught. And the reason is that the standard was written very carefully and very intentionally. And that's what the standards were based on. If we stray from that, we may not be teaching the things that we're supposed to be teaching to students at the end of the day. It might have been great stuff, but it's not part of the standard itself. And so here you can see the framework for the life science standard I picked, the pages for that, and the bit.ly link there actually takes you just to that chapter in the framework itself. Or you can look in your own copy of the framework that you may have. After we look at the framework to guide our ideas, we're going to formulate some claims in complete sentences. What are things that students need to know from that framework? Those are the facets in there, the different ideas. We need to consider the background knowledge. And then we're going to write a student explanation that's in full sentences that explains things. So let's go through these steps. We're going to start with the framework. So for LS1-1, by the end of 12th grade, this is what they're expected to know. Now, I can't cover all of that in one unit. There's a lot of information in here. So I looked at the sections I might cover in one unit, and I put those in the bold here in the black. That chemical reactions take place between proteins and nucleic acids, and all cells contain genetic information in the form of DNA molecules. Genes are just regions in the DNA that contain instructions to code for the formation of proteins, which carry out most of the work of cells. Starting from there, I need to come up with a student explanation. Now, I could have a student explanation that looks like this one with the phenomenon of just simply DNA translation. And historically, this might be what your lesson would have been. Just, hey, this is the chapter on DNA translation. Well, it's got some good information about Oswald Avery and other scientists who determined how proteins are coded from DNA. It tells you about how genetic information is with three-letter codons, which are then turned into protein sequences, and that mutations can cause the protein structure to be mutated in different ways, and so they're no longer active. The problem is that this is not a very engaging discussion. This is very broad as well, so it doesn't fit the basic definition of what a good phenomenon is that we learned last time. So to help us make sure we're finding a good phenomenon, we're going to start with formulating claims. And so looking at our standard again, LS1-1, we need to come up with the facets. And the facets here, people like to equate them to a diamond or a gem. That we have each of the flat surfaces on a gem are one of the facets or one of the key pieces of the gem that makes it the precious stone that it is. And so our facets here, the DNA sequence determines a protein sequence. We're going to have protein sequence determines how the protein will fold. The shape and sequence of the protein determines the function of the protein, and DNA mutations or even protein mutations in the sequence may impact the function of the protein. So that's what we're going to try to focus on in this unit is this piece, and that's a pretty broad amount of information there. What do students need to know as they come into this chapter or this unit where we're going to be talking about, well, DNA is double-stranded and made of 4 bases, and then we get our DNA from our parents. So now I've set kind of the groundwork, and I can start thinking about how I can use DNA sequences and protein mutations and things to impact the protein shape and function as we go forward. I can start generating a list of ideas. And so one, for instance, might be this, the Siamese cat coloration. And again, I want to have a student explanation. And when I do that, I want complete sentences. And this is kind of that, what should a student be able to explain at the end of the day that, at the end of the unit, excuse me, if they learned everything, if they can explain it in detail. And you want to make sure this is as detailed as you think your students should be able to do. So Siamese cat coloration was my phenomenon. And Siamese cats have black fur around their face and tails and feet. The rest of the body is white. That's a basic observation. The black coloration comes from the production of the pigment melanin, which is the same chemical that's actually found in humans to cause our different skin and hair colors as well. Melanin is produced by an enzyme called tyrosinase, which oxidizes the amino acid tyrosine, which is itself a precursor to melanin. So once I oxidize that, I can make melanin. So in Siamese cats, a single nucleotide polymorphism or a single base pair mutation in the tyrosinase gene changes GGA to AGA. So one single letter base pair change changes it from a glycine to an arginine amino acid in that one spot. And it changes the shape of the amino acids, which changes the structure of the protein. That change, that single base pair change, makes tyrosinase heat sensitive. And so at the normal body temperature of the cat, along their sides, they actually no longer are able to make tyrosinase functional. Therefore, they no longer break down tyrosine, which means they no longer break down or turn into melanin. So cooler temperatures at the feet, tails, and face, it's just a couple of degrees cooler, but tyrosinase is able to function normally, which then allows that melanin production, which gives it the black fur at those other body parts. So you can see how a detailed student explanation can tie back into my claims here. Do we talk about DNA sequence determining protein sequence? Yes. Do we talk about protein sequencing determining how the protein will fold? Yes. Does the shape and sequence of the protein determine the function of the protein? Yes. And do mutations in the sequence impact the function of the protein? Yes. So since I've covered the facets I needed to cover, this makes it an academically productive phenomenon. This is a good one to start exploring more and trying to write a unit around. So finding a phenomenon out there, we start with our framework, unwrap the standard. We are going to look for the facets of the things that we need to be talking about, and then look for a phenomenon to use. Now, you may have your own favorite phenomenon out there, and I know Christine is out there, and she's got one. It's not a life science standard. So Christine, do you want to explain yours?
So for my physical science people, I chose to use LiDAR, and to give a specific instance where we might see LiDAR being used would be in the new self-driving vehicles. This would touch on the PS4 standards. I specifically was thinking the bundle of PS4.1 and PS4.5, where we have to look at the relationships between wavelength, velocity, and frequency. And then PS4.5 talks about communicating how technical devices use different wave behaviors in order to function. And so I identified just a few facets. I did this really quickly. So some facets where the kids might have to be able to explain would be things like light travels in waves. Waves are characterized by their wavelength and frequency. Light waves can be reflected, absorbed, or transmitted. And when those light waves are reflected, that gives us some information that we can follow up with about what happened in the reflection. So it might give some information about the objects that it was reflecting off of. And then you could also tie in some Doppler effect in there as well. And so using those phenomena, the student might come up with a discussion about how the light waves travel out from the self-driving vehicle, that the particular light wave that's being used, which I haven't researched yet, but the different light waves that are being used would have a certain wavelength and frequency. And then when they reflect off an object, the speed at which they come back tells us how that, using the law of reflection, like where that object is in space and how that allows the self-driving vehicles to start and stop when needed and reduce their speed.
All right, so I know you're not here to share with us, but this is that moment where you get to start reflecting on what is your phenomenon. What is the thing that you found interesting that you want to determine if it's an academically productive phenomenon?